Hi everyone. In today's video, we are going to look at plotting your experimental spectral data and observe the change in wavelength as your nanoparticles are placed in varying refractive index solutions, as well as generating a bulk sensitivity plot for this data. So we begin by importing the spectral data from Excel using the Excel read function. So you can see here in the first column, contains our X values in which are in nanometers, and the remaining columns represent our absorbance spectra for different refractive index solutions. And so these refractive index solutions might be a little bit different to yours, but it's still the same code. You would just adjust some of your commenting. So the next step is we want to focus on a specific range of our data. And in particular for gold nanoparticles, we're interested in our absorbance resonance peak between 500 and 600 nanometers. So we can use this indices to just say, we can create this indices to say we only wanted to take X values between 500 and 600. So next, we want to normalize the data between this X and Y range that we've set. So each spectrum here is normalized within this selected range. And this is done by subtracting the minimum value and dividing it by the range, so the max and min, to scale the data between 0 and 1. And this is important because it helps us directly compare spectra and highlight small shifts in our spectrum, which is what we really want to see. So now that we've done this, so key thing to remember is we are now generating a bunch of new things to call. So we have Y1 norm, Y2 norm, Y3 norm, Y4 norm, Y5 norm. So these are now our new Y values. And as you can see here, we're doing it between our specific X values that we've mentioned up here. So we want to plot this normalized data. So we can use just the plot X and Y function, but we need to be careful because we only want to plot between our indices. So that's why we've got the indices in brackets, and we want to plot our new normalized data. So our Y1 norm, our Y2 norm, Y3, Y4, and Y5. And importantly, we're using this hold on function so that we're telling MATLAB that in our figure, we want to plot all of these Y values on the same plot. And then we can add a hold off afterwards. Yep. And so we are generating some X labels, a Y labels, and a title, and we're making sure our legend is shown. So importantly, we are also putting display names in. So for each Y1, for each Y set of Y data, we're telling it that we want it to be called the specific refractive index, and this will show on our legend here. So let's go and run that and see what it looks like. So what I'm doing now is I'm just making sure that this is its own section. So we can just run this section of code and it will take a minute. But you can see here, we've got our plot and it's normalized. So everything is between 0 and 1. We have our titles and our axis, our legend, and all of this information is stored in our workspace. So you can always refer back to it if need be. Okay. So now that we have this data, we want to actually generate a bulk sensitivity plot to tell us something about how sensitive these plasmonic nanoparticles are to changes in refractive index. And so the way we do this is we do this by creating a somewhat of a calibration curve. And we perform a line of best fit, and we use a linear fit, so y equals mx plus b, to model this relationship between the refractive index and peak shift. And so what we need to do first is we need to find the x and y values that correspond to the peak. And so we do this by creating some variables. So we know that our y1, the peak on our y1 data and its corresponding x location. And so we just do that. So once you've got it for one, you can copy it and just make sure that you're changing the location 1, 2, 3, 4, and 5, and you're looking at the different y1, y2, y3, y4, and y5 data sets. And the same for the corresponding x values. And so now these will all show up in your workspace, but to have it so that it's easier for you to interpret, we're just going to generate some code that allows us to display these values for us in our command window, so they're easy to quickly refer to. So we do that by creating a display, and we say the x value for the maximum point in y1 norm is, so this is just printing some text, and now we're saying num to string, so we're generating some text to include the exact x and y1 values here that we've kind of already created up here. And so we can run that to show you what that looks like. So I can run this section now. And you can see here, we have a nice little information about our spectra. So you can see here that as we increase the refractive index, we see a shift in our spectrum. Except for this last value, you can see here, it actually goes backwards. That is probably an experimental error. So if you wanted to improve your fit that we're going to do, you can remove any of these kinds of outliers from your data. Should make it easier for you to have a better fit. But yeah, so now we're going to move on. So now we have these values. So the next step is to plot this linear relationship. So we need to create a matrix for our refractive index values, which we have here. Yours, again, might be different to mine. And the x max values, which we printed above. And so we can call them through here. So our x max and y1, y2, y3, y4 max, right? So now we need to fit the line. So to do that, we need to create a linear fit. So we can do that through this line of code and then generate the plot. So now we need, so we can also now generate the plot, but we want to fit the x and y fitted lines, which we do through this 2 lines of code. So for both x and y. And importantly, we want to calculate our R-squared values. So this R-squared value tells us something about how well our data follows this linear relationship. So that is done by this quick calculation. But I will also show you a way to do this inside the figure window after this. So then we just need to plot everything. And so now we're just going to plot a scatter plot of our refractive index values and our x max values. And we have a display name, which we're just going to call peak position. And going to use this hold on again so that we can plot our fit and then add our labels in. So the next thing is we want to display the equation and the R-squared value. And so we do this by using this sprintf. And so essentially this allows us to print the equation of the equation of our fit and also the R-squared value. And this funky thing here, this is just telling MATLAB how many significant figures we want. So if we change it to 4, for example, you'll see that happen. Yeah, and so we're just generating a text box to do this. So if I press run on the code, yeah, also it's also worth noting that this is just also this fx, so it's saying there it's in the form of our like y equals mx plus b. Yeah. So we can just run this section and you can see we have everything here that we need. You can see you can move this to the correct location, and our fit is not so good. So perhaps if you were doing this, you would probably want to remove some of your outliers. But as I said, I was going to show you how to do this fitting inside the figure window. So I'm just going to remove all of this. So I'm just going to edit the code slightly. So I'm going to create a new section. Yeah, so we're just going to create a scatter plot for our RI values, which are here, and our X max X values, which are here. And then we can just this, and then we're going to say that, let's say F bigger, so F3, so we can just call this F3. Right, and so now let's just run this section of code. Yeah, so now you can see we have our scatter plot. So now how do we have our R-squared value and our linear fit inside the figure window? Well, we can go to tools and we can go to basic fitting. And inside the basic fitting window, we can, well, when it pops up, we can request a linear fit for our data. And there is our equation, and we can change the number of significant figures as well. And we can also ask to plot our R-squared values. And we can make it look a little nicer by clicking this edit plot tool, and we can move this to the bottom. And to change these colors, it's quite easy as well. You can make this whatever color you want. So let's make it red. Let's have these be, for example, the X's. We can change all of that stuff. And then inside here, we can also change the text. We can add a box around the text. We can add a background around the text. So yeah, however you like to represent your data. And we can also add in our titles in here as well. But what we should do is show you how to code that. So let's close this. So we can do that by just showing exactly how we do that down here. So we can grab this kind of text, pop it back up here. And yeah, we can also add some labels this way. Yeah, that's it for this little video.